Welcome back to Remote Sensing Applications using ArcGIS. Here is one of the 6 mini projects that you can choose from. And in this mini project, what we'll do is look at the trend in maximum NDVI from 1982 to 2006 within 3 ecoregions in Alaska. So our 2 ecoregions north of the Brooks Range are the Arctic coastal tundra, and then along the foothills, the Arctic foothill tundra ecoregion. And we'll find that the NDVI trend since 1982 is increasing in these 2 cold ecoregions. The other ecoregion that we'll investigate is the Yukon interior dry forest ecoregion, and the NDVI trend has been declining within that region because typically the boreal forest in this region is limited by moisture. This is a hot continental climate during the summer, and it's frequent that drought affects the productivity within this region in the summertime. So these are the 3 ecoregions we're going to look at, and then ultimately we're going to come up with the linear trend in the 3 ecoregions. So this will be the end product that you'll email me, the linear trend in annual mean maximum NDVI for this coastal tundra ecoregion. So we've got a strong increasing trend. The Arctic foothills ecoregion, we've got a strong increasing trend. And then the interior dry forest ecoregion, we've got a stronger declining trend. So then the question is, for each of these trends, what's the R-square of that linear regression line? So what's the R-square for this Arctic foothills linear regression line, the coastal tundra linear regression line, and the dry forest declining trend linear regression line? Okay, so this will be the end product that you'll email me as the mini project if you choose to do this mini project. Okay, so if you go to the Blackboard website, I give you a link for where to download the data for this mini project. And what you'll have is the maximum NDVI for each year from 1982 to 2006, and then the ecoregion polygons. So what I did was I ran the zonal statistics as table to get the mean maximum NDVI value within each ecoregion. So for example, for the 1982 maximum NDVI raster, for each polygon that has a different eco name, give me the mean NDVI value. So I did that for you for the 25 years from 1982 to 2006. And you'll get those DBF tables when you download the data for this mini project. Okay, so when you download the data for this mini project, you'll have the zonal statistics mean for each year from the GIMMS-NDVI, the maximum NDVI for each year, for each pixel within those polygons. So we could just upload all these tables. So if you add data, select 1982, hold the Shift key down, select the last table, and that way you can add them all at once into your data frame. So here's what they'll look like. So basically we've got for each ecoregion that we're interested in what the average NDVI was for that year. So this is the maximum NDVI in each pixel, and then within this polygon what the average of that maximum NDVI was. Okay, so now what we want to do is we'll merge these all together into one table, and to do that we'll use the merge tool. So the easiest way to use this merge tool is to browse to the folder where you have your DBF tables, and then select the 1982 table, hold the Shift key down, and then select the 2006 table. So we'll add all 25 tables into our input data sets. Okay, and then we'll output it to another DBF table. I'll call it ecoregion mean NDVI 1982 to 2006.dbf. And then just OK. So we have 25 years times 3 ecoregions, so that gives us 75 records. And what we would like to do is rearrange these so that we have, for example, the Arctic coastal tundra, the first year, 1982, as our first record, and then the Arctic coastal tundra, 1983, our second year, as our second record. So what we'll do is we'll add a short integer field, and let's just call it record number, whatever you want to call it, and make that equal to the object ID. So field calculator equal to the object ID. So now we've got from 0 all the way down to our last record is 74. So now what we'll do is run the sort tool, and we'll sort based on this field and based on that field. And that way we'll have all the Arctic coastal plain, all 25 years, will be at the top of the table. So the next step is to run the sort tool. Okay, so I name my output table sorted ecoregion mean NDVI 1982-2006.dbf, and then we'll sort by our field eco name, so sort ascending, and then sort by our field record and sort ascending, and then just OK. So we have all the Arctic coastal tundra records at the top of the table and all the Yukon interior dry forest records at the bottom of the table. So we would no longer need this field, so we'll delete it. And then we have to check our work. So this should be 1982, 1983, 1984, 1985. So let's check, is this the NDVI from 1985? So here's our NDVI means from 1985. Open that table, and then arrange the tables horizontally. So here is the same value from 1985. And we'll do one more check. So let's go down near the bottom. So here's Yukon interior dry forest. This should be from 2006, 2005, 2004, 2003, 2002, 2001, 2000. So then we'll look at that table from 2000. So open the NDVI mean from 2000, and then arrange tables horizontally. So the selected one was Yukon interior dry forest, and here is Yukon interior dry forest. So they check out. So now we've got a table that's been sorted, and it's sorted by ecoregion name and then sorted by year sequentially. And it's a DBF table, so we could open it in Excel or any other program that you want to do your linear trend analysis in. So now we'll just exit out of ArcMap. Okay, so there's a DBF file and there's an XML file, and they'll both have the same first names, but they'll have different extensions. So if you have extension hidden, look at the type. We want the DBF file. So we'll right mouse click open with, and then you could use whatever program you want that you use to make linear trends. I'll use Microsoft Excel. And then what we want to do is we'll save this as a Excel spreadsheet. So save as Excel workbook. And then what we could do is we'll format this column of average NDVI from each year. So format cells, nothing to the right of the decimal, because they're whole numbers ranging from 0 to 10,000. So we have the mean NDVI, and then we have our ecoregions. So I'm going to give the Arctic coastal tundra some different color. So I'll color those red. And the Arctic foothills, I'll give some different color. So I'll color them brown. And that way I can quickly tell when I'm outside a different region. So then what we want to do is we'll add the year. And the year starts in 1982. Then we could say this year is going to be equal to this cell plus 1. And then we would just drag that formula down to our last year should be 2006. And our last year is 2006. And then we could just copy this range of values, and then we'll paste it for our Arctic foothills tundra. So paste those values. And then the same thing, we could paste those values for our interior dry forests. So now we've got for each year what the mean maximum NDVI was by ecoregion. So I'll save my work. And then we'll insert a scatter plot and develop a linear regression line for the data for each ecoregion. So insert, menu, and then we'll insert a scatter plot. And then select data. So the first thing I want to do is I'll add my series name. And then the X value will be the year. So the year I'm going to select as 1982 to 2006. And then the Y value will be the NDVI. So that's the NDVI 1982 to 2006. And then you say OK. And then you can do the same thing, add the next series, which would be the Arctic foothills tundra, and then add the next series that would be the interior dry forest. Okay, so we've got our plot. So in this case, it's just coastal tundra. So then what we could do is right mouse click on your data and add a trend line. So we'll add the trend line, and then to see the R square, you would say display R square on chart, and then just close. So there's our trend line for the coastal tundra. And then you would basically repeat the process for the Arctic foothills. So if we add, select data, we'll add our series name, and then its X value will be the same. It will be 1982, 2006, and its Y will be NDVI value during that time period. And then our last one will be interior dry forest. The X value, once again, is the year, 1982 to 2006. And the Y value is that annual mean maximum NDVI value. And then just OK, and then OK. So there's our plot. And then we would add the linear trend. And you would say display R square. And then we'll add the linear trend for our interior dry forest. And then you'd say display the R square. And then you can format this any way you want. So you could, for example, get rid of these linear and you could change this line color. So we'll change that line color to, let's see here, solid line blue. And we'll change this line color to solid line green. Let's see. Etc. So then you would send me the R square in a plot for this line of increasing NDVI for the foothills, this linear regression line increasing NDVI along the coastal tundra, and this declining trend line, this linear regression for the interior dry forest ecoregion polygon.